Thank you very much for coming back to our channel today. We are going to be doing something very important, and that's question number 11. Very important. So to do this question, we need to use knowledge from question number 9 and question number 10. So if you haven't seen those two, check them out in the videos that we've recorded. So we have the limit of the ln of x minus 3 or divided by x minus 4 as x approaches 4. We are going to go right ahead to evaluate this limit. But remember that we're going to use this rule to evaluate this limit. The rule that says that the limit as x approaches a number a of, in fact, x approaches 0 of the ln of 1 plus x all divided by x, this entire thing is 1. That's the rule we're going to use here. So the first thing before using that rule, we have to rewrite the limit as x approaches 4 of the ln of the square root is x minus 3 all raised to the power of 1 over 2. That's what the square roots mean. All divided by x minus 4. So what happens? This half will drop. So you have 1 over 2. The limit as x approaches 4 is 4 of the ln of x minus 3 all divided by x minus 4. Great. Once we've had this, then it is in a form in which we're about to use our little, trick. So we're not going to do a substitution, we're not going to change a variable, we're not going to do something like that. We're just going to use our little trick to evaluate this. So we say we replace x with x plus the limiting value, in this case 4. So I'm going to replace x with x plus 4. We're going to have 1 over 2, the limit, as x, instead of x now, we have x plus 4 approaches 4 of the ln of this x is going to be replaced with x plus 4 and then minus 3 all divided by this x is going to be replaced with x plus 4 minus 4. Great, so we have this 1 over 2 is half 1 over 2, the limit as x approaches 4, we send it 4 across. So we're going to create sign changes. Obviously, 4 minus 4 is 0. So the limit as x approaches 0 of 4 minus 3 is 1. So it's the ln of x plus 1 all divided by 4 minus 4, you just have an x. So we want to rewrite it. We have 1 over 2, the limit as x approaches 0. This will be the ln of, rewrite this one, is 1 plus x all divided by x. So what you're seeing there is you are seeing the exact same expression here. The limit of the ln of 1 plus x all over x. And we say the entire thing is 1. So now, our final answer is going to be 1 over 2 onto this entire limit. And I'm going to write that in black. The limit as x approaches 0 of the ln of 1 plus x all over x. And we said this entire result is 1. So you're going to have 1 over 2 multiplied by 1, and that's just half. So the result for that limit is 1 over 2. Thank you for watching, and see you. Today we are going to be doing question number 20 on the midterm exam paper for Math 201 section 1, and that's section 4. So question number 20 says, find the values of a and b so that the limit of f of x as x approaches a and the limit of f of x as x approaches b exists, given that f of x is this piecewise defined function. So for x less than or equal to b of a, for x less than or equal to a, f of x is 3x plus 2. For x between a and b, f of x is 2x minus 1. Oh my god. And for x greater than or equal to b, f of x is bx minus 4. So take your own time, grab a bottle of cold water and sit as I drill you through the process. So the first thing you need to do here is to redefine this expression for the second expression here. So for this second definition, we have a and b combined, so we can split them. Now we have the very same expression, so the solution begins from here. We say L of x is equals to piecewise defined function. It is 3x plus 2 if x is less than or equal to a. Now, it is 2x minus 1 if a is less than x. In other words, if s is greater than a. So it is 2x minus 1 for this first one if s is greater than a. And then it is the same 2x minus 1 if x is less than b. So it is 2x minus 1 if x is less than b. And then it is bx minus 4 if x is greater than or equal to b. Great. Now, the concept of right hand limit and left hand limit is about to be introduced right here. And to get that done, we need to understand which one is the right hand and which one is the left hand. So we could draw the normal line like this, and then we locate A and B. So let's say this is A and this is B. Obviously we don't know their value, so we don't know which one is to the right or to the left. But then when we say x is less than or equal to A, that means the value that is less than A are all on this side. So because it's less than, so we say x is approaching A from the left. So here, there is a left hand limit. X is greater than A, it means it's on this side. So x is approaching A from the right. This from the left, this from the right. So this is a left hand limit, this is a right hand limit, and this less than is a x is less than B. This is B. If x is less than B, that means x value is on this side and x is approaching B from the left. So this is a left hand limit, and this is also a right hand limit. So let's quickly move on to evaluate that. For the limit of L of x to exist, for the limit of L of x as x approaches A to exist, that means the limit of L of x as x approaches A from the right should be the same as the limit of L of x as x approaches A from the left. So for this limit to exist, the right hand and the left hand limit must exist and they must be equal. If they are not equal, then the limit does not exist. So let's find the limit of L of x as x approaches A from the right and from the left. Let's do that right now. So we have the limit. What is L of x as x approaches A from the right? As x approaches A from the right, L of x is 2x minus 1. So the limit of 2x minus 1 as x approaches A from the right should be equal to the limit. As x approaches A from the left, we have 3x plus 2. The limit of 3x plus 2 as x approaches A from the left. Now, once you have this, you can move on to simplify. You have to do direct substitution in order to simplify. So we apply direct substitution right here. We have 2a, so replacing s now with a. 2a minus 1 is equals to, replace s with a, you have 3a plus 2. If you have this to solve for a, you have to collect leg terms and then solve for a. So to collect leg terms, we send the 3a across. So we have 2a minus 3a is equals to, the 2 remains here, this goes across, it becomes plus 1. So we can continue right here. We have 2a minus 3a is negative a. Negative a is equal to 3. To solve for a, divide this out by negative 1, negative 1. So a will be equal to negative 3. This is the value of a. Simple as it is. So now let's move on to find the value of b. Do not panic. Let's move on to find the value of b. Quickly. So to find the value of b, we'll be evaluating the limit of L of x as x approaches b from the left, and that should be the same as the limit of L of x as x approaches b from the right. So for the left hand limit, for left hand we have 2x minus 1. So it's the limit of 2x minus 1 as x approaches b from the left is equals to the limit L of x approaches b from the right is bx minus 4 as x approaches b from the right. Now once we have that, we can actually move on to evaluate that limit. So to evaluate that limit, here we have to do direct substitution. So we have 2b minus 1 is equals to, now x approaching b, so replace x with b. Put x here, so put b here, you have b times b. That's b squared minus 4. So here we have the limit of 2x minus 1 as x approaches b from the left is equals to the limit of bx minus 4 as x approaches b from the right. And then we replace x with b, so we have 2b minus 1 is equals to, here we replace this x with b, so it's b times b, that's b squared minus 4. So there's a quadratic equation in b, and we need to send this across. So we send everything here across, we have 0 is equals to, now if we rewrite this b squared, we have b squared minus 4. This 2b comes across, it becomes minus 2b, and then this 1 goes across, it becomes plus 1. In other words, we have b squared minus 2b minus 4 plus 1 is minus 3. Minus 4 plus 1 is minus 3 equals 0. B squared minus 2b minus 3 equals 0. To solve b, we factorize the expression. So we have b minus 3 times b plus 1 equals 0. So to solve b, we have to use the zero product property. That says that we should let each of these things equal to 0. So b minus 3 equals 0, in which case b is equal to 3, or b plus 1 equals 0, in which case b is equal to negative 1. So a is equal to 3, a is equal to negative 3, b is negative 1 and 3. So a has one value and b has two values. That is it. B minus 3 equals 0, b is equal to 3, b plus 1 equals 0, b is equal to negative 1, and then you have that. So thank you very much for watching, and we hope to see you in future episodes of our epic and classic videos. Take a screenshot of the solution and see you next time.